Till now, we have talked about the handshake in theory, but now let's get practical. Let's look at IMS reference implementation and study each payload as it moves through the system. By looking at the logs in the tool and platform, we can see the exact JSON being traded in real time. So, when we click perform launch in RI platform, the first thing it does, it sends up heads up to the tool's login initiation URL. As mentioned over here, for the algebra activity we registered. It is simple, unauthenticated call. Think of it as platform tapping the tool on the shoulder. So considering the specific attributes being sent, first is the issuer. It tells tool exactly which platform is calling. In our case, this is IMS RI platform itself. Next is login hint. It is the opaque ID for the user. The tool doesn't know who they are yet, but it will use this to ask them in next step. Target link URI. This is the final destination. This is the exact URL of the content the user is trying to reach. A tool might have hundred of different resources, a quiz, a video, or a textbook chapter. The platform uses this field to tell the tool, once we finish this handshake, this is the specific page you need to show the student. Next is LTI message hint. This is internal sticky note. This is opaque string generated by platform for its own use. When the tool redirects the user back to the platform in step 2, it must include this exact hint. It helps the platform remember the context of the launch, like which resource or session was being accessed, without the tool needing to understand this data. LTI deployment ID. This is like installation ID. When the client ID, while the client ID over here defines the tool software, the deployment ID identifies a specific instance or installation of that tool. A university might have one client ID for a textbook tool but different deployment IDs for different departments. It allows the tool to distinguish between different organizational units within the same platform. As discussed earlier, client ID is tool's username. This is the unique identifier issued by platform when tool was first registered. We give it as training course 1. So let's hit post request. So now step 1 has been done, and in step 2 the tool receives the heads up and immediately fires back. This is the OIDC authorization request. Instead of simple data pack, the tool issues a 302 redirect to the user browser, sending it back to the platform's OIDC auth endpoint. So here we have received all the parameter we just discussed in init request from platform to tool. Now tool is generating a challenge response which seems like this. Here response type ID token is sent. This is the format request. This tells the platform exactly how to send back the data. By specifying ID token, the tool is saying, don't just give me a code. I want a fully digital signed JWT that contains the user identity. Redirect URI. This is the return address. This is the tool's endpoint where the platform should send the final JWT. The platform checks this against the redirect URI saved in its own configuration. If they don't match perfectly, the platform will block the launch to prevent data from being sent to malicious site. Scope Open ID. This is the permission level. This is standard OIDC requirement. It signals that this request is specifically for identity verification. In the LTI world, this is the handshake protocol that says we are following the OpenID Connect standard to prove who the user is. Next, we have state. This is the context keeper. This is another random string generated by tool to maintain state between requests. Since the browser is bouncing between a tool and platform, the state helps the tool remember what it was doing before the redirect happened. It's like a bookmark for tool's internal session. Login hint and LTI message hint is same as we discussed in the earlier payload. Next is prompt, which is set as none. This is silent. This says this is a silent request. This tells the platform not to show any login screen or allow access button to the student. Because the student is already logged in into LMS, the handshake should be invisible. The student isn't logged in, the platform will simply return an error rather than interrupting the flow with a login box. Nonce. This is anti-hacker token. This is random one-time use string generated by tool. This is the most critical security feature. The tool remembers this string when the platform sends the final passport JWT in step 3. It must include this exact nonce. If the nonce doesn't match or has been used before, the tool rejects the launch, effectively stopping the replay attacks. Now let's send this request. After this, we are on the step 3. The platform has verified the user and is ready to fulfill the request. It bundles all the user data and their role course info into a JWT. So finally, our JWT is visible over here. It looks something like this. This is the JWT actually which will be sent, and this is the decoded version of it. Here we can see the message type is LTI resource link request, as we are trying to open a resource, and we have name for the user and email. Also we have roles. Roles define the permission list. This is a list of URI defining what user can do. Instead of just saying student, the LMS standard has its own vocabulary. The tool sees learner, hash learner, and knows it has to show the quiz. Or if it sees hash instructor, it know it has to show the gradebook. Next we have resource link claim, which denotes which resource we are trying to open, its ID, and its title we have set in the configuration. Then we have the context claim. It is just like a room number. This contains ID and title of the course we, from which we are launching this resource. It allows the tool to automatically put the student in right virtual classroom. Example, it will put the user to mathematics class without student having to search for it. Next, we have some platform information over here. Then these are some endpoint which we will use for callback, where we would send the score to the to the platform back from the tool. As we discussed, LTI Advantage has three uh, extra perks. One was name role service among them. So this is the URL from which we can receive the entire roster for the specific course. Along with this, we have issuer same as earlier uh, payloads, and we have audience. This tells which is the target tool. This contains the client ID of the tool. The tool checks this to make sure the token was actually intended for it and not accidentally sent to the wrong place. If audience doesn't match the tool client ID, then it will reject the token. We also have IAT and EXP, which states issued at and expiration of this specific token. It is the lifespan of this token. This is denoted in Unix timestamp. IAT denotes when this was born and EXP denotes when it will expire. LTI tokens are very short lived, usually from 1 to 5 minutes. This prevents the hacker from stealing a token and trying to use it later. We also have deployment ID and target link URI which we discussed earlier. We also send some custom param which can be required as a custom information we need to share from platform to tool. Here we can notice we also have nonce. This is the return value which we received earlier. It is for the security match. This is the exact same string the tool has sent. The tool looks at its database and say, did I recently ask for a launch with this ID? If yes, it accepts the login. This is the final log that prevents man in the middle attacks. We have discussed all of the claim parameters. Now we can hit perform launch, which will finally launch the resource for the user. The RI tool takes the public key we pasted in the configuration during uh, our setup and verifies the signature on that JWT. If the signature matches, then only the successful launch is visible to us. So, we have discussed all the parameters which are sent between calls. In next video, we would explore more on deep linking.